In this section, we will be matching polar equations to their graphs and identifying common features in different families of curves. For this, you will need the card sort linked to the polar coordinates topic. We're also going to look at how to find the maximum and minimum value of r for a polar curve, and also find the equations of any tangents at the pole. Using the polar coordinates card sort, first of all, match each of the curves to their polar equation. When you've done this, try to put the equations into 3 groups based on different properties of the graphs. So here are the curves and equations matched. We're now going to look and see if we can put them into groups based on different properties. So these 3 could be grouped together based on the fact that they all involve the cos theta function in some way. Now, because the cos theta graph is symmetrical about the y-axis, functions in polar form involving cos theta only will be symmetrical about the initial line where theta equals 0. So in this case, if you were to sketch one of these curves, you could consider what the graph would look like for values of theta between 0 and pi, and then mirror this to get the other side of the graph. So in this case, it would be important that your curve was symmetrical, as you would get marks for this. Next, we can consider these graphs here. They all involve the sine theta function in some way. Now, functions involving sine theta only are symmetrical about the vertical line theta equals pi by 2. This is because the line of symmetry for the sine theta graph, y equals sine x graph, is also at pi by 2. Therefore, you can consider values of theta between minus pi by 2 and pi by 2, and then reflect the graph to find the other half. Here we have the graph r equals 8 theta minus theta squared plus 2. We want to consider what is the greatest value of r that this curve takes. In other words, the furthest point on this curve away from the pole. We can see that the curve seems to move away from the pole, and then at some point it starts to move back towards the pole again. We also want to know which value of theta would this occur. Now, by inspection, we can see it's about there, but how would we find it if we were calculating this? It seems to be where r is 18 and theta is 4 radians. Remember that in radians, 4 is about here. We could prove this result using differentiation, basically finding stationary points, because this would give us maximum or minimum values. So the maximum or minimum value of r can be found by finding dr by d theta and setting it equal to 0. This will find either a value where we have a maximum of r or a minimum. So finding dr by d theta would give us 8 minus 2 theta. We can set this equal to 0 This gives us theta equals 4. When theta is 4, we can then calculate the value of r from the original function. This gives us r equals 18. We would need to check that this wasn't a minimum value by finding the second derivative in the same way that you would do with a Cartesian curve. You may also need to check the endpoints to make sure that, that these values are not maximums or minimums in themselves. So if the curve is going from 0 to 2 pi, you would also check the values of r at 0 and 2 pi and check that neither of these are larger than the value you found. Here we have the curve r equals 6 plus 4 cos 3 theta. We want to find the greatest and least values of r and the values of theta that these occur. Now by inspection, we can see there appear to be 3 maximum values here and 3 minimum values here. Now we could use differentiation for this. However, if we haven't seen differentiation of trig functions yet, there is a way we can do this just by considering maximum and minimum values of cos theta. So by inspection, we can see that there are 3 maximum values, and we can see the values of theta where they occur. We can also find 3 minimum values and the values where these occur. So what we could do is we could consider the fact that the sine and cos functions have a range from -1 to 1. So therefore this function here will have its maximum value when cos 3 theta is equal to 1. It will also have its minimum value when cos 3 theta is equal to -1. Therefore 4 cos 3 theta will be between -4 and 4. So 6 plus 4 cos 3 theta varies between 2 and 10. This is where the minimum of 2 and the maximum of 10 can be found. So the maximum value of r equals 10 occurs whenever cos 3 theta equals 1. We can use trigonometry to solve this. 3 theta would need to be 0, 2 pi or 4 pi, which means theta will be 0, 2 pi by 3 or 4 pi by 3. And the minimum value r equals 2 occurs when cos 3 theta is -1. This occurs when 3 theta is pi, 3 pi or 5 pi. So therefore theta will be pi by 3, pi or 5 pi by 3. We're now going to consider a polar function. R is a function of theta. If r tends towards 0 as theta gets closer to a value alpha, then we can say that r equals alpha is a tangent to the curve at the pole. This is a straight line from the pole. So we're going to consider the curve r equals 4 cos 3 theta here. We want to find the values of theta when r equals 0. So we can see by inspection there seem to be one about here as the curve gets closer and closer to 0, one about here as the curve moves away from 0, and another here, 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 and here. So the tangent to the curve is a tangent that also goes through the pole. So we need to find the values of theta such that r is 0. So we're going to set 4 cos 3 theta equal to 0, therefore cos 3 theta is 0. There are 6 values for this in the range theta is between 0 and 2 pi, therefore 3 theta is between 0 and 6 pi. So here are the values for theta where r would be 0. These tangents correspond to these lines. This is the line theta equals pi by 6. This is the line theta equals pi by 2. This is the line theta equals 5 pi by 6. the line theta equals 7 pi by 6, the line theta equals 3 pi by 2, and finally theta equals 11 pi by 6. We're going to consider the curve with polar equation r equals 150 plus 9 theta squared minus 2 theta cubed for values of theta between 0 and 2 pi. We're going to find the maximum and minimum values of r and the values of theta for which these occur. I'm going to sketch the curve by creating a table of values of theta and plotting the points. So pause the slide now and answer the question. So we can find dr by d theta. This is going to be 18 theta minus 6 theta squared. At a maximum or minimum point, we need this to equal 0. So dividing by 6 gives us 3 theta minus theta squared is 0. So we have theta times 3 minus theta is 0. This potentially gives us theta equals 0, theta equals 3. These are potentially going to be maximum or minimum points. We also need to consider the other end point, theta equals 2 pi, as this may also have a value that is bigger or smaller than the maximum or minimum, but may not be a stationary point in itself. So we're just going to calculate the second derivative, d2r d theta squared. This gives us 18 minus 12 theta. So we can see that when theta equals 0, we get the second derivative is 18. So there is a minimum value at theta equals 0. At theta equals 3, we get a value of minus 18, which is less than 0. So we also have a maximum point potentially at theta equals 3. However, we're just going to find the r values at each of these 3 points to check whether 2 pi is larger or smaller than either of these. So when theta is 0, r is 150. When theta is 3, we get an r value of 177. And when theta is 2 pi, we get an r value of 9.21. So here we can see that theta equals 3 is indeed a maximum, as we expected. Although there is a stationary point, or a point where it changes direction at theta equals 0, the minimum value of r actually occurs when theta is 2 pi. So actually the minimum value is at 2 pi, not at 0. Now, sketching a table of values of theta and plotting r and theta, we arrive at this curve here. We can see that the curve starts at this point where theta is 0 and r is 150. We travel around the curve until we reach a maximum. This is at theta equals 3, which is slightly less than half a turn, because half a turn will be 3.14. This is the value of 177, which is the maximum we calculated. R then starts to decrease until we arrive at the end point where theta is 2 pi, and we have an R value of 9.21. R would continue to decrease beyond this, as this isn't actually a stationary point, but since the curve only goes as far as 2 pi, this is where we're going to stop. So 9.21 is the minimum point we are considering here. We're now going to consider the curve with polar equation r equals 5 minus 2 cos theta for values of theta between 0 and 2 pi. We want to find the largest and smallest values of r. So if we were able to differentiate, we could use differentiation for this. However, we can also use the fact that cos theta has a minimum value of -1, a maximum value of 1. Therefore, 2 cos theta has a range from -2 to 2. Therefore, the minimum value occurs when we have 5 minus 2, which is 3. The maximum value occurs when we have r equals 5 plus 2, which is 7. The values where these occur, r is 7 when theta equals pi, and r is 3 occurs when theta is either 0 or 2 pi. This comes from when is cos theta equal to -1 and when is cos theta equal to 1. We can sketch the curve, remembering that a curve involving the cos function will be symmetrical about the initial line. We can plot a table of values, and this is the curve. Now complete exercise 6b on page 118.